Hello friends, in this video we will explore scatter plot. So mainly scatter plot illustrates the relationship between two variables, and one will be represented on x-axis and the other will be represented on y-axis, and both variable has to be in the continuous data scale. Okay, so in this our example data set, pathway, tissue, GDR, these all are categorical data, okay, because there are categories involved, and the other points like mutation, D1, D2, D3, D4 till D6, these are 6-7 columns, those are in the continuous scale. Although scales are different, but there is a continuity in the values are there. So these are continuous scale. Okay, so if you now we can choose any of these two variable and try to see how they are related to each other. So that means, let's say if you are interested in how the gene expression is varying between D1 and D2, or let's say how the relationship between expression in D1 versus the number of mutation on that gene. So this way you can choose any of these continuous two column and try to find the relationship between these two. So whether there is a positive trend, there is a negative trend, what is the correlation, those kind of thing, the scatter plot will give you information about. And the function that we will be using, basically the layer what we will be using is GUM_point. So point is for the scatter plot. Okay. So let's if our objective is to try to see the relationship between total number of mutation versus the expression of D1. So then what we can do, the simple command will be ggplot. First parameter will be the data frame, let's say DF, and then we give the aesthetic mapping where x equal to D1, so that means D1 on the x-axis, and y, let's mutation will be on the y-axis. And then once this aesthetic mapping is done, then you say plus and add in point layer. So in that will, so in our example there are 5,000 genes are there, and each gene will be 1 point. So that means, let's say if this is one of the gene, so we say that its number of mutation is around, let's say 7,000 over here, and the D1 expression will be somewhere between 0.7, 0.8. So that way each point here represents one single gene and the relationship between D1 and mutation. So let's do this example. Yeah. So okay, so you say first ggplot. So let me clear, I was doing some trial here. Okay, ggplot, the first parameter df, this is our data frame. So you might have seen in the previous video that we have already loaded the data. So head g df, this is our data frame. So to run, so let's ggplot, and first argument you pass df, then let's put an aesthetic mapping, and x equal to d1 and y equal to mutation. Again, once again, you do not have to put the quotation mark here, directly you can use this thing. And once that is done, let's add in point. So this already we had done it. Okay, so now the relationship between D1 and mutation is like this. Okay, so this is our first plot. So now let's add another variable or aesthetic mapping, and that means color this point with respect to the GDR as the categorical variable over here. So now you see our GDR, there are this thing is there, I mean so many categories are there. So how will you know? You say $df, let's say GDR, and simple put into a table function. Okay, this will give the distribution of how the GDR, that means gene to disease to ratio, this categorical variable, the distribution, that means 139, definitive, limited. So these are the 5 categories are there. Okay, so now let's see, and you can see that majority of them are no evidence, the genes with no evidence one. So we will be color them with respect to GDR. So the command will be simple. So ggplot, everything is same, just we have to add one more aesthetic. Let's map this color aesthetic with the column GDR. Okay, and rest everything is same. So the moment you do it, what it will do, it will, you see that the points are now colored, and the color legend automatically ggplot draws. That means red one is definitive GDR, limited, moderate, no evidence, strong. So 5 different colors are there over here. So let's say we want to categorize them with respect to pathway. So you say that you pass over here pathway here. So that means here now we are drawing x and y, but we are using the color with respect to pathway. Okay, so now you see that there will be 7 pathways are there, right? And the distribution will be different. And similarly, if you want to color them with respect to, let's say, third categorical variable, which is, let's say, tissue. Okay, and you will see that you will have the tissue as the by which the points are colored. So this way we can specify the x and y aesthetic along with the third aesthetic color equal to GDR. So now you can see there are some 5000 points are there. That's why these lots of overlapping happens. So so then we can use another parameter called alpha for transparency, so that we can provide transparencies over here. Okay, so let's see what I will do. Color is with respect to GDR, and since it is the transparency we are giving to the point, so you have to pass the alpha property, to the geometric point function. So this is not an aesthetic, this is an additional property of the point, so we have to put in this point function. Okay, and the alpha, let's say the value between 0 to 1, where 0 is equal to this thing and means transparent, and 1 is equal to opaque, so let's say 0.2. Okay, let's give 0.2. so you will see that it is slightly fainter color. Okay, if you just further reduce it, it will be further reduced. So let's give some higher value, let's say 0.6. So it will be slightly opaque or dark in color. So this way, anywhere if you want to paint your colors or something, transparency, so you can use this alpha property, and that you have to pass within this point function. Okay, so next concept we will see, like, okay, we will now add another aesthetic, that is shape. Okay, and let's this time provide shape to the tissue. Okay, so what will happen now? X is equal to this, y equal to mutation, color with respect to GDR, but now shape with respect to the tissue. Again, do not put any quotation mark. So now we have given two further aesthetic. So indirectly this is in a 4-dimensional plot. X is 1 dimension, 2D, 3D and 4D. So 4-dimensional four properties we are plotting in a single plot. Okay, so let's see. Okay, so if you see that, now you can see that we have two categories. One is the color is with respect to the GDR property or GDR categorical variable, while the shape is with respect to tissue. So we have blood, brain, breast, so these all are in different symbol shapes are there. Okay, so let me remove, and you get some warning over here. What is the warning? Like in our case we had 8 such categorical data. Okay, so that's why the recommendation up to 6 clearly you can give symbol, and beyond that you will not able to provide any symbol. So that's why the warning message what you got is that because more than 6 is difficult to discriminate, so up to 6 only you can provide the shape. And yeah, and some of the missing values were there, so those were removed, those were not drawn over here. Okay, so this way you provided we can provide another attribute shape over here. So let's now one more attribute provide size. Let's increase the size of the point. So now everything is uniform size, right? So we now size with respect to let's say a continuous variable. So what will happen, based on the size of D6 the plot will be drawn. So again, where you will write it here, this is aesthetic mapping, so you have to write in the AES function. So let's say size is with respect to D6. Okay, so let me rerun over here. So what happens here, so now you see that size 3 area, like anything 50 or less than, those will be in this shape, this size, and 50 to 60 is this size, and 70 and above, those are this. So it automatically divided into 3 category. So let's do one thing. Instead of D6, if you do, what happen, like size is with respect to, let's say D5. Okay, so it will change accordingly, like 55, 60, 75, D5 is also in that scale. So let's just try D4. Okay, yeah, so now you see the scale change like 4, 6, 8, 10. So anything, so that now it automatically breaks your D4 into 4 different scales and 4 different beans, and based on that it provided shape. So now you can see this is a 5-dimensional plot, we can say, because 5 dimensions means 5 property we are visualizing on the same side. X, Y, this is 2 column. Third is the color. Fourth is the shape, and 5 is the size. So this way, in a simple way, in the aesthetic mapping, you can assign which column corresponds to which aesthetic property, and at the end you simply add the point layer so that it will draw the point. Okay, so we have, in summary, what we have seen, like we have, so yeah, so we saw that basic X and Y, then we provided the color, then we added the transparencies here, so that will provide the transparency, then we added the shape attribute, and then we added the size attribute. Okay, so this way you can draw any kind of scatter plot between any two continuous variable and add additional categorical variable, consider them for other properties like color, size and shape. So in the next video we will now add the trend line, which is useful like to see how the overall trend goes between the interrelationship between these variables. So we will see that. So thanks for watching this video. I hope this was really useful, and please like it, and yes, if you have not yet subscribed, please subscribe it. Thanks a lot. Thanks for watching.